The Carboniferous period, part of the Paleozoic era, takes its name from large underground coal deposits that date to it, formed from prehistoric vegetation. The majority of these deposits are found in parts of Europe, North America and Asia that were lush, tropically located regions during the Carboniferous. In the US, scientists divide the Carboniferous into two parts, the earlier Mississippian and the later Pennsylvanian. The growth of these forests removed huge amounts of carbon dioxide from the atmosphere, leading to a surplus of oxygen. Atmospheric oxygen levels peaked around 35% compared with 21% today. Insects do not breathe the same way that we do. Instead, the insect's respiratory system relies on a simple gas exchange that bathes the insect's body in oxygen and expels the carbon dioxide waste. Oxygen travels to insect tissues through tiny openings in the body called spiracles. Arthroplura is a genus of millipede arthropod that originated during the late Carboniferous era in what is now North America and Europe. A distant relative of modern millipedes and centipedes, measuring 3 meters long, it was the largest known of all terrestrial arthropods, as well as the largest land invertebrate of all time, and grew so large because of the high concentration of oxygen. Despite its large size, Arthroplura was herbivorous. In fact, one of the first mainly herbivorous terrestrial animals. They had very strong jaws, but it is unlikely that they may have been poisonous for defense. Meganeura is likely to have hunted and fed in much the same way as dragonflies do today, although its larger size may suggest that many more creatures could have been on the menu for it. Aside from other invertebrates, potential prey may have also included small amphibians that were rapidly evolving to terrestrial life. With a wingspan measuring 75 centimeters, these eagle-sized dragonflies are described as the rulers of the Carboniferous skies. The high oxygen level in the Carboniferous period allowed this creature and many others to grow to a very large size. Like modern dragonflies, Meganeura was carnivorous. A higher amount of oxygen in the atmosphere would supply a passive boost to these tissues with no effort on part of the Meganeura, allowing for larger growth. However, falling oxygen levels after this period would mean that the giant insects simply did not have enough oxygen to maintain their size, resulting in either the evolution of smaller forms or outright extinction of the larger. Edaphosaurus was a primitive herbivorous relative to mammals that is found in fossil deposits dating from late Carboniferous to early Permian periods. Edaphosaurus was more than 3.5 meters, 11.5 feet long, with a short, low skull and blunt conical teeth. The head was very small in comparison, with a massive barrel-like body. More distinctive, however, was the large sail on its back, formed by elongated vertebral arches. The arches were probably connected by a membrane that had bony knobs or crossbars along its length. The sail may have functioned in thermoregulation and also may have served as a storehouse for phosphates, which could have easily mobilized from the bony projection supporting the sail. The sail also may have had a defensive function, giving the animal a larger and more imposing appearance to predators. One unexpected side effect of all this coal being formed, however, was that CO2 in the atmosphere was increasingly sequestered underground. Because of this, the Earth began to rapidly cool down, and by the end of the Carboniferous, a full-fledged ice age had developed, one which came very close to locking our planet in a permanently frozen state. This meant that many of the large insects we saw during the Carboniferous died out, and we would have to wait until the Permian era for Mother Nature to breathe some life into this cold, icy planet.